Welcome all of you to my YouTube channel Statistics and Data Science. This is Rishikesh Kadam. In this tutorial, we are going to implement a simple linear regression using Tenserflow 2.0 library. So first of all, we are going to import all the basic libraries as well as Tenserflow library which are required for our analysis. So let's execute our command line. Now we are going to import one dataset consists of only one variable, one exploratory variable and one target variable. As we know, in simple linear regression, there is only one exploratory variable and one target variable. That is nothing but we try to predict our target variable using that exploratory variable. So here we have to wait for some time to see our dataset. So because TensorFlow basically is a heavy module, so that's why it's require time to load. So you can see here x is our exploratory variable, y is our target variable. We try to predict y variable using this x variable. So first of all, we are going to assign our x variable as x and our target variable y as a y. After that, we are going to reshape our exploratory variable because we need it in our any deep learning model, because we have to convert our exploratory variable into from one dimension to two dimension, because necessary requirement of deep learning algorithm is that our input should be in the two dimension. That is so that's why we have to reshape it in between -1 and +1. So let's execute our command line. Now we are going to split our dataset using train test split command. Here we can see we try to split our dataset into 80% and 20%. 80% training dataset, 20% testing dataset. After that, we are going to normalize our dataset using standard scalar command, because in deep learning it is necessary to normalize our data, because for the evaluation of our model, for training our model very correctly, because we need normalization of our data for that deep learning model. So we try to normalize our data using standard scalar command, because here we apply standard scalar on xtrain and xtrace dataset. So let's execute our command line. Now we are going to import the input function, dense function, activation function and dropout. These are the some important function of TensorFlow keras.layers library. So we try to import it from tensorflow.keras.layers library, and after that we try to import the model function from tensorflow.keras.models. So let's execute our command line. After that, we are going to build our model. Here we can see we try to provide input, that is nothing but shape of our exploratory variable, x variable. After that, we are going to apply some dense layer consist of 100 units. 100 units are nothing but total number of neurons present in that layer. So first dense, this is the first dense layer. We try to provide input layer to it. Here we use activation function as ReLU, rectified linear unit, as activation function. So it is most probably used in regression algorithm, that's why we use ReLU here. After that, in the second dense layer, we try to provide 50 number of neurons and activation function as ReLU. Again, input to the second layer is in our output of the dense layer 1. After that, we provide third dense layer consists of 25 number of neurons and activation function is ReLU, and input to the third dense layer is dense layer output of the dense layer 2. After that, our output layer consists of the 1 unit, and this input is nothing but dense layer output of dense layer 3. Now we are going to build our model. First, providing input layer and output layer. After that, we are going to compile our model using loss function as mean square error, as a optimizer as Adam optimizer. After that, metric is accuracy metric is mean square error. We try to check accuracy using mean square error. Now let's execute our command line. After that, we are going to fit our model on xtrain and ytrain dataset, and here we provide batch size equals to 2, as well as number of epochs is nothing but 100, and verbose is equals to 1, validation split nothing but Here we try to convert our training data set into training data set and validation data set. So for that we try to use validation split as a 0.2, that is 20% validation data set. So let us execute our command line. Here we have to wait for some time. Here you can see we are trying to train our model on 192 samples, 192 observations, and validate it on 48 samples, that is 48 observations. Here we have 100 epoch, that's why we have to wait for some time, because it will take time to execute. So this is the required procedure for applying simple linear regression. Here we use two variables. X is our exploratory variable, y is our target variable. That is, we try to predict y variable using this x variable. First of all, we are going to reshape it. After that, we split it and normalize it. After that, we are going to build our model using this command line. Here we use 3 dense layers. After that, we are going to compile our model using Adam optimizer and loss function as a mean square error. Now we are going to execute. Now our model is executed. After that, we are going to check our accuracy using square root of mean square error. So for that, we have to just import mean square error from metric library, that is from sklearn, and square root from math library. After that, we are going to predict our x-train using model.predict command. So after that, we are going to check the accuracy using square root of mean square error. So let's check accuracy of training dataset as well as testing dataset. So here you can see our training dataset accuracy is 3.08, that is equal mean square error for training dataset is 3.08, and mean square error for square root of mean square error for testing dataset is 2.91. It is quite very low. So that's why we can say our model is executed very well and our accuracy is also very well. So you can see mean square error for training dataset is only 3.08 and mean square error for testing dataset is only 2.91. So it is very low. So that's why we can say our model is very well fitted. So this is the required procedure for applying the simple linear regression. So this is the basically accuracy of our simple linear regression model using Tenserflow on training dataset, and this is on testing dataset. So this is the required procedure for applying the simple linear regression using Tenserflow library in Python. So thank you all of you. Please subscribe my channel, hit the bell icon to get notification of my new videos. I am trying to make better videos concerning with the data science. So thank you all of you. Please subscribe my channel and hit the